There you go. All right. So, like I said, today is, oh my gosh, every daggone time. All right. So, like I said, today is just kind of more of a review day from Math 1. We're going to be talking about everything dealing with polynomial vocabulary as well as how to add, subtract, and multiply polynomials. So, why is polynomials important in terms of a quadratic unit? Well, a quadratic is a type of polynomial. All right. And we'll discuss in just a second what that means. Okay. So, the first part's pretty vocab heavy. Let's see if you guys remember some of this stuff. So, again, it's polynomial vocabulary. So the first thing is a polynomial is an expression with one or more terms. Now, can anyone tell me what a term is? What counts as one term? Lucas.
What do you mean, like 4x squared?
Right. So if we look at the problem, a term will be 4x squared, 28x is a term, 49 is a term. All right. It's essentially any type of multiplication division. Terms are typically separated by pluses and minuses. Okay. So the minus and the plus here are what separates these three terms. Now, there are some special names for polynomials with 1, 2, and 3 terms. Does anyone remember what it's called if a polynomial has one term? Lucas.
Is it monomial?
Monomial, right. So if it has exactly one term, it's called a monomial. So that could be 8x squared, that could be 49, that could be 4x. All right. That's just some examples. Now, if you notice, mono in Latin means what? One. All right. So take a shot in the dark. Who thinks they can tell me what a polynomial with two terms is called? Claire. Binomial. So an example could be x plus 2, x squared minus x squared plus 4, so on and so forth. All right, so that's an example of a binomial. All right, someone want to take a shot in the dark and tell me what a three-term polynomial is called? Let's go, Eli. Trinomial, good. So trinomial is three terms. So x squared plus 6x minus 9, or 2x squared plus 4x minus 3, etc., etc. Now, does anyone take a shot in the dark of what a polynomial is called with four or more terms? It's just called a polynomial. All right. So we only have special names for the first three. All right. After that, we just call it a plain old polynomial. So if it has four terms or more, it's just a polynomial. Because does anyone know what the root poly means? Many. Good. So an example of that would be 3x cubed minus x squared plus 4x minus 2. All right, so that's actually a cubic function, which you guys will learn about in Math 3. Now, like I mentioned earlier, the different parts or pieces of a polynomial are called its terms. If those terms have the same variables and the same exponents, they are called what? Like terms. Good. So same variable and same exponent, they're called like terms. If a term has a variable, the number multiplying directly in front of the variable is called the what? Coefficient. Now, someone who has not talked yet, if a term does not have a variable, so it does not have a variable, it's called a what? So in other words, the term that does not have a variable would be 49 up here. What's that called? I heard it. What is it? Constant. So again, this is some stuff that you learned back in Math 1, so it should be starting to ring some bells. Okay? So, first things first, we're going to determine whether it's a monomial, binomial, or trinomial. So, just to get this kind of rolling, what I want you guys to do is, for A, B, and C, hold up the number of fingers that you think it is. So if it's a monomial 1, binomial 2, trinomial 3. Okay? So I'm going to close my eyes for letter A. Hold up the number of fingers. 3, 2, 1, go. Good. It is a binomial. There are two terms. All right. For B, 1, 2, 3, go. Good. It's a monomial. There's only one term. Then for C, 1, 2, 3, go. Good. It's a trinomial. Does anyone have any questions on how you would determine which is which? So remember, what separates a term is plus and minuses. So for that monomial, even though it has two variables, it's technically still one term because all of that's being multiplied. All right. Now, for 2, we're determining whether it is like terms or not. So thumbs up for yes, thumbs down for no. All right. So letter A, 3, 2, 1, go. Yep, they are like terms. Same variable, same exponent. All right. Letter B, 3, 2, 1, go. Right, they are not like terms. They do not have the same variable, x and y, so it's a no. What about C? 3, 2, 1, go. Nope. They do not have the same exponent. And then D, 3, 2, 1, go. So I see a little wobble jawed here. Some are saying yes, some are saying no. However, what's true about multiplication? It doesn't matter the order. What property is that called? Do you want to remember? Not distributive. There's the C. Nope. It's the commutative property of multiplication. It means that whatever you're multiplying, order doesn't matter. So technically speaking, these are like terms. All right. Because you can easily rearrange negative 3yx to 3xy and it'll be the exact same thing. All right. So yes, they are like terms. All right. Now we're just going to list coefficients and constants. Now, what is the key difference between a coefficient and a constant? So, between a coefficient and a constant, what's the difference? How do I know which is which? What? Whether it has a variable or not. Which one has to have a variable? Coefficient. Constant does not have a variable. So, remember, these are only numbers. So, for each of these, it's a number. So, for the letter A, will 7 be a coefficient or a constant? It's a coefficient. It's attached to a variable. Is 1 a constant or coefficient? Constant. There is no variable. What about -4 letter B? Is that a coefficient or a constant? Coefficient. It doesn't have a constant. What about -9? Is that going to be a coefficient or a constant? Constant. There's no variable, so it doesn't have a coefficient. So, -5, is that a coefficient or a constant? Coefficient. What about 4? Constant. Now, I'm missing a coefficient for letter D. 1. So, there's an unspoken 1 here, so that's technically one of my coefficients. So remember, if you just see a variable, there's still a coefficient there. It's just an unspoken 1. All right. Any questions on that, guys? Fairly easy. Again, this is all review. Now, some more vocabulary with polynomials. A monomial is a number, a variable, or a product of numbers and variables with a whole number and exponents. So it's a number, a variable, or a product of numbers and variables with a whole number exponents. So, polynomials will not have, all right? Polynomials will not have fraction exponents. They will not have a variable under a radical. And they will not have negative exponents. Negative exponents dash a variable in the denominator. Okay, so polynomials are strictly, all right, at positive whole number exponents, all right, and there should be no radicals anywhere with a variable under it. Now, let's say you had square root 2 times x squared where the x squared's outside the radical. That's still technically a polynomial. All right. It's when you stretch that radical out. So like that, that's when it's not a polynomial. So that x falls under the radical, it's not a polynomial. So just so you guys kind of know what it looks like, a fractional exponent would be like x raised to the 3/2. Square root of x raised to the -2 power, and 1 over x. All right. If you see any of those, it's not a polynomial. All right. All of these have different function names, but it's not in the polynomial function family. All right. So polynomials are often classified by their leading No, it's usually classified by their degree, which is the term with the highest exponent. So, basically, whatever your highest exponent is, that's what classifies your polynomial. So, if we were looking at the one from today in standard form, what's the highest exponent here? 2. So we would say this has a degree of 2. All right, whatever that highest exponent is, that's what degree is. So, a polynomial with a degree of 0. So, for example, let's say I had 4 times x raised to the 0 power. Well, does anyone remember what x raised to the 0 power is equal to? 1. So what is this actually equal to if I simplify? 4. What do you think that's called? You just have a singular number, no variable. What's that called? Constant. That's all it's called. So if the degree is 0, that means it's just a singular number. So it's a constant. There's no variables anymore. Now, if it had a degree of 1, so that could be x to the first plus 2, which, remember, anything raised to the first power is just x plus 2. So I'm specifically talking about this. What type of function is that called? You did a lot of these back in Math 1. Starts with an L. Linear. So if it has x plus 2, it's known as a linear function. It has a degree of 2. So that means there's an x squared somewhere in there. So, for example, it could be 4x squared plus 3x minus 5. All right? It contains that x squared. That is called what this entire unit is about. So what do you think it's called? A quadratic. Then a degree of 3. All right? So it contains an x cubed somewhere. So let's say 5x cubed plus x squared minus 3x plus 2. What type of function do you think that's going to be called? Cubic. Just for funsies, if the degree is 4, what do you think it's called? So it has an x to the 4th power in there. So quadratic, cubic, quartic. So quartic is a degree of 4, quintic is a degree of 5. Now, you really only need to know these first 4, but, brownie points if you can remember quartic and quintic. Okay. So, all polynomial expressions should be written in standard form. All right. I brought this up in your warm-up this morning. Does anyone remember what standard form means? Danny? Not quite. Audrey? Right. The terms are in order from highest to lowest exponent. All right. Meaning that the terms are placed in descending order. So exponents go from highest to lowest. All right. Not talking about the coefficients, I'm talking about the exponents. So notice how with some of my examples up top, like for example, the cubic one, notice how it goes 3, 2, 1, 0. All right. I automatically put it in standard form. Okay. It's not in standard form if, let's say, I have big 2 like this. Same function, it still has a degree of 3. It's just not in standard form. All right. Now, the blank is the coefficient of the term with the highest exponent. Does anyone remember what that's called? So the coefficient connected to the variable with the highest exponent. Does anyone remember what that's called? You guys remember the leading coefficient? So you'll hear that word a lot, leading coefficient. It's the coefficient of the term with the highest exponent. So for example, if I look back up here, for my degree of 3 example, what would be my leading coefficient? 5. It's the term that's connected to the highest exponent, or the coefficient that's connected to the highest exponent. All right. What about here? What will be my leading coefficient? 4. It's the coefficient connected to the variable with the highest exponent. All right, so we're just going to do one of these together. So let's do letter B. So first off, how would I put this in standard form? It is technically a polynomial. So before we do that, first off, can I do some simplification before I even do that? What would I do? Divide all the terms by 3. So technically I can split apart this fraction as 15 over 3 plus 12x squared over 3 minus 9x over 3. If an entire function is over a number or a value, you can split it up to go to each term. So this would be 5 plus 4x squared minus 3x. So if we were to put that in standard form, what would it be, Natalie?
4x squared minus 3x plus 5.
Right. So it'd be 4x squared minus 3x plus 5. Now, we didn't discuss what a leading term is. A leading term is basically whatever term holds the leading coefficient. Okay? So, Natalie, pick someone to tell me what the leading term is. All right, so what's the leading term here? That's leading coefficient. What's the leading term? It's the entire term with the 4. Right. So leading term would be 4x squared, and like Nate said, the leading coefficient would be 4. So the leading term is the entire term that contains leading coefficient, and the leading coefficient is just a number. All right. Nate, pick someone to tell me the constant. Positive 5. Good. Tucker, pick someone to tell me the degree. So what's my highest exponent? 2. So Eli, pick someone to tell me what it's classified as. It's quadratic. Good. And then lastly, Danny, pick someone to classify by the number of terms, so the type of polynomial it is. Good. So that's all you would do for these, okay? It's just a matter of putting it in standard form. The leading term is usually that first term when you go in standard form. The coefficient is that first number in standard form, and so on and so forth. Any questions on that? All right. Okay, now going into adding and subtracting polynomials. So guys, I'm going through this really quick because you guys should be pretty familiar with this by now. All right. So, adding and subtracting polynomials. What's the main thing you do whenever you add and subtract polynomials? What's the main strategy to add and subtract polynomials? Combine like terms. Good. So, when we add and subtract polynomials, it's only about the like terms. So we add and subtract like terms. We only add and subtract the coefficients, all right? The variables stay the same. So I like to say you add the numbers and then slap the variable that's connected to them on at the end. All right? So again, don't add those exponents. Now, you can either use the horizontal format or the vertical format. And the subtraction is the same as addition, except what's the one extra step that you have to do first? So if you're subtracting two polynomials, so like if we look at the first example down here, if I remove this, how do I subtract those two polynomials? What would I have to do first? How to do what? Flip the signs or distribute the negative of the term connected to the minus. All right. So it's the same as addition, but you need to distribute the negative first. All right. And then you always write your final answer in standard form. So get into the habit of writing your answers in standard form. All right. Yes. So let's look at this first example. All right. So we're adding and subtracting. So this is a kind of mix of adding and subtracting. All right. So what do you think should be the very first thing I do? Anyone got an idea? Right. I want to take care of that negative first, just so I have everything with like terms. Okay. So I'm going to go ahead and distribute this negative. So I'm going to rewrite everything without parentheses. All right. But also distributing the negative to those last three terms. So I have 5 minus 9x squared minus 3x plus 5x minus x plus 2x squared. All right. So that just all stays the same because they were just adding them. Then what are my last three terms after I distribute the negative? Negative 7x squared, negative 2x squared, and negative 6. Now, because this is so many terms, I like to, yes ma'am. I did. Thank you. All right. Now, because there's so many terms here, I recommend either using colors or different shapes. What I mean by that is that when I'm trying to figure out where my like terms are, I either highlight them different colors or I draw different shapes around them. So if you don't have highlighters, draw like a circle around one type, square around another type, triangle around another type, heart around another type. All right. So I'm going to use different colors, but you're welcome to use different shapes as well. And if you want colors, there's some on the shelf if you want to grab them. But let's go with Shelby. Can you tell me one set of like terms? 5 and negative 6. All right, so our constants. All right. Shelby, pick someone to tell me another set of like terms. Preferably someone who hasn't talked yet today.
Well, I meant like 9x.
Yeah.
And then negative 7x.
Good. So all the x squareds. All right. Elizabeth, pick someone else. Good. And then since the 5x cubed is on its lonesome. We still have it as a different color, but it's just kind of there. Now, again, if you wanted to go the shape route, let's say I did triangles for my constants. I did squares for my x squares. I did circles for my x's. And I did a heart for my x cubed. Okay, that's another way you could have done it. So I did it 2 different ways. You don't have to do the shapes if you already did the colors. Okay? But if you didn't have colors, that's how you can do it. You can just use different shapes. And again, the reason that I do this, even though you guys are honors kids, I'm assuming that you guys know, like, you can separate out all the like terms. It's just so you don't forget anything. Okay? Because it happens. I do it all the time. I get caught up in something and I'm like, oh crap, I forgot this term. Which would include this term. Okay. So we want to write our terms in standard form. So, Ashlyn, since you were the last person to talk, pick someone to tell me what the first term would be in standard form. Mm-hmm. Right. So the 5x cubed would come first, and since there's no other oranges or hearts there, there's nothing to combine. All right. So pick someone to tell me what the next part would come, or what the next type of term that would come next. So it'd be the x squareds. Now, Reynolds, if I added them together, so I did -9 plus 2 minus 7, what would I get? So -9 plus -7 is -16, plus 2 is -14. Good. So this would be -14x squared. So Reynolds, pick someone else. Tell me my next term. All right, so Sailor, what's the next type of term that has to come next? So it's the x's. Good. So if we combine the like terms, what would the coefficient be? So -3 minus 1 minus 2. It is in fact negative what? You're good. Oh, you're okay. You're good. -6, yeah. All right, and Sailor picked the last person to give us our last type of term. All right, so it's -1. So in other words, it's my what type of term? Constant. So then -1. So this would be my answer. And yes, I know I did not write it in the answer spot, but it's too small anyway. So, and Bradley, pick someone to tell me the degree. So it's cubic or degree of, what's the number? 3. So it is cubic, but I'm just going to say it's a degree of 3. So again, in parentheses, I'll put cubic. Blake, pick someone to tell me what the leading coefficient is. All right, Claire, what's the leading coefficient? So that's the leading term. If I want leading coefficient, it's just the 5. All right. Do you guys really need to see me do number 2? Yes, no, maybe. So guys, all number 2 is it's just in vertical form. Okay. So like, you know how if you do addition, sometimes you can see it like 14 plus 8. It's basically the exact same thing, but it's in vertical form. So I would distribute the negative first. So I would get 4n squared leave some space, plus 5, all over 2n squared plus 2n minus 4. And the reason I left some space here is because since we don't have an n term up top, it's basically just saying, okay, this is how I know which ones to combine to. So if I add them with the like terms, because if you notice now, the like terms are all lined up. This would be 6n squared plus 2n plus 1. So that's just the vertical version of that. Oh, yeah, you're right. See, Miss Murphy makes mistakes all the time. Son of a biscuit. There we go. See, I made the most common mistake. I only did the first term and not the other two. Now, for number 3, we're just going to talk about how you would set this up. Okay? So for number 3, if we're talking about the perimeter of a rectangle where the length is represented by 2x squared minus 3x plus 6 and the width is 3x squared plus 2x, how would I figure out what expression represents the perimeter? How do I find the perimeter of a rectangle? Add up all the sides. Now, let's draw a picture here so we kind of know what's going on. So this would be 2x squared minus 3x plus 6 and 3x squared plus 2x. All right. If I'm adding up all the sides, that means I have to write each expression what? Twice. Or, to save me some time, I can do what? Multiply it by 2. So if I want to set it up, I'll do 2 times 2x squared minus 3x plus 6 plus 2 times 3x squared plus 2x. All right, and we're not going to simplify this. You can if you want to. But essentially, you would just distribute first, then combine like terms, because PEMDAS. You multiply before you add. So you would distribute and then combine the like terms. All right, do we need to see any more examples with combine and like terms? You guys pretty solid on this? So thumbs up if you're good, thumbs to the side if you're like, I kind of get it, but I still need a little bit more work, and thumbs down if you're just completely lost. All right, good. Okay. So moving on. Now we're talking about multiplying a polynomial by a monomial. So any type of polynomial, so whether it's 1, 2, or 3, or 4 terms, etc., by a monomial, so a one-term polynomial. All right. You use the distributive property, which you guys are very familiar with that, and the product rule for exponents. Okay, so what that means is that the product rule for exponents just states if you multiply, let's say 3x squared, and I cubed it, you would multiply that exponent to every piece inside the parentheses. So the 3, since it's technically a base, multiply the 3 to it, multiply the 3 to the 2. So this would be 3 cubed x to the 6. All right, you just multiply the exponents. And remember, you're multiplying variables with the same base. Oh, crap. Okay, that's not the product rule. That's the power rule. Good Lord. The product rule is if you have x squared times x cubed, what do you do with the exponents? You add them. So this would be the same thing as x raised to the 2 plus 3. So x to the 5th. Sorry, guys. My brain apparently did not brain today. So the one I just stated was the power rule. And my brain was there because that's what my math 3s are doing right now. So, okay. So, and remember, because a lot of people mess this up, coefficients, you just multiply like normal. Okay, so if it's like 3 times 1, it's still 3 times 1. If it's like 3 times 7, it's 3 times 7. Okay, exponents are the only thing that you add. So for number 1, if I was to distribute, what would be my first term? Let's go with Blake. So it'll be my first term when I multiply the 3x squared.
3x.
Good. So we would do 3 times 1, the unspoken 1 there, and then x squared times x to the first. So you just add 2 and 1, you get 3. What would my next term be, Nathan? Negative 21x squared. Good. You just do 3 times the negative 7, slap on the x squared at the end. Any questions on that one? All right. Now, number 2 is a little bit more difficult because they threw in 2 different variables. Okay, so remember, you only add the variables, not the variables, you only add the exponents to the variables that are exactly the same. Okay, so if I multiply everything here, let's just do this by the coefficients first. So in other words, I'm multiplying the coefficients by the coefficients. So I'm distributing 1/2 to all 3 coefficients. So what's 1/2 times 2? 1. So remember, if you multiply 1/2 to something, it's the same as doing what? Divide by 2. So this will be 1. I'm going to leave a little space. What's 1/2 times negative 10? Negative 5. What's 1/2 times 6? Plus 3. All right, so I left some space because now we got to do the variables. So now I'm going to look at the x's. The unspoken x here. So what's x times x squared? X cubed. So we'll write an x cubed next to the 1. What's x times x? X squared. And what happens if I'm multiplying x to something but there's not an x there? Right, it's just 1x. So do you guys understand what I'm doing right now? All I'm doing is breaking it apart, so it's just one at a time. And you can totally do this with any distributed problem. Okay? So x times x squared, I added the 2 exponents to get 3. X times x, I added 2 to get 2. X times 0, or x is 0, I added them 1 plus 0 is 1. Lastly, the y's. So y cubed times y squared is what? Y to the 5th. What about y cubed times y? Well, y squared, it's still y to the 5th. What about y cubed times y cubed? Y to the 6th. So this would be my fully simplified expression. Now, if you have 2 different variables, don't worry about standard form. It's a whole another monster. I just expect standard form is just if it's just a singular variable straight across. All right. All right. Any questions on this one? Do we need to do another example? Or do you want to try one? All right. So why did we bring up multiplication with a monomial? Because that leads us into multiplying binomials, which you kind of already did this morning in your warm-up. All right, so this is the last part that we're doing today. Okay, guys, we're almost done. Because today we had to fit in all the review stuff with polynomials. So just the basic operations. So there's two methods for multiplying binomials. One is FOIL. And remember, FOIL stands for first, outer, inner, last. So if you did first times first, that would give you the x squared. Outer, that's the two terms that are the furthest to the outside of the equation. So x times 2. Actually, let me do that in a different color. So x times 2, that gives you the 2x. The inners is the ones inside. So it's where the kind of the two sets of parentheses kind of meet. 3 times x is 3x. And then the last two terms. 3 times 2 is 6. And then you would just combine the like terms, which is just the 2x's. And it would give you this. Okay. So again, this shouldn't be anything new. You learned this back in Math 1. All right. Also, guys, if I'm ever going too fast, just let me know. Okay. All right. So let's look at B. So if I do FOIL, all right, Clark, if I do FOIL, what would I multiply as my first for part B? 8x times x, which would give me what? 8x squared. All right, Clark, pick someone to do the next part. All right, so I want the outer now. So what's my two outer terms? 8x and negative 4. So if I multiply them together, what would that give me? Negative 32x. Pick someone to do the next part. All right, so Tyson, inners. What's my two inner terms? Negative 3 and x. Multiplying together to give me what? Negative 3x. Pick someone to do the last one. I think like pretty much everyone's been picked at this point. So
Negative 3 times negative 4 equals 12.
right, negative 3 times negative 4 is 12. All right, so let's go with Sailor. If I combine like terms, what would my final expression be? And then what? Good. So we really only had to combine the two x's there. Oh, I'm sorry, Amelia. I guess you haven't been picked. Well, Amelia, tell me how I would start writing out part C. Right. So that's what I was going for. So we're not going to do part C because it's very similar to what we did in the warm up today, and you guys were fine with that. But just remember, if you see any binomial squared, it means you're multiplying it by itself twice. Okay, it does not mean distribute the square and square the two terms inside. All right, any questions on FOIL? Okay, very quickly, we're going to do a box. All right, so box is the other method. Now, the great thing about box is that it kind of gives you a bit more of a visual, more organized method. Especially so, my rule of thumb is foil is great if you're doing a binomial times a binomial. As soon as you throw in a trinomial or any polynomial bigger, you need to use box method. All right. Because I can guarantee you, like, say, for example, if you did part E, foiling that, I can guarantee you, you will miss at least one term. All right. So I highly recommend that if you're doing anything besides a binomial times a binomial, I highly recommend you use box method. You can still do foil. It's not really foil anymore because there's like some extra terms thrown in there. All right. So with box method, all you do is you create a rectangular box with the first polynomial as one side and the second polynomial as the other side, and you calculate it by multiplying the length times the width. So in other words, you can think about it as row times column. And then to find the total area, we combine like terms using the area of the individual pieces. So in other words, this kind of turns something algebraic into a geometric problem. All right, that's why a lot of people like box, because they understand how to find the area of a rectangle. It's pretty much that. Now, to the right of that is just an example of how you would set the box up. Now, how confident are you guys with setting up a 2x2 box? So a binomial times a binomial. You guys pretty confident with that? Okay. Let's do a 2x3. Okay. So knowing how to set up your box, it's based off of the number of terms in each polynomial. So if we look at letter E, this is 2 terms by a 3 term. So we're going to have a 2x3 box. So when I build my box, how many little boxes, if I'm doing 2x3, will be inside my box? 6. So I'm going to do 2 rows and 3 columns. Now, you could have done 3 rows and 2 columns, same thing. Okay, it doesn't matter. So you could have made it look like this, and it would have been the same thing. All right, it doesn't matter. I typically go for the horizontal way. All right. So I'm going to put my 2 term on the side because that's where I have my 2 rows. And then my 3 terms over the top. So remember, you always do the row times the column. So for the first box, I would do x squared times x to give me this box. So essentially, you just line up the row and the column for the box you're trying to find. Okay? So take a minute, fill in that box on your own. So take a minute and fill in that box on your own. And remember, you're multiplying, so make sure you're using those product rules. Also, when you finish that box, go ahead and pull it out and combine like terms to get an answer. Thumbs up if you're ready. All right. Check your answer. So this is what I got inside my box. What I circled along the diagonals are my like terms, and that's usually pretty nice with boxes. Yet, what I do? I wrote it here, but it did not transfer. See, guys, I do it all the time, and I don't care to slow me out. All right, Miss Murphy has her dumb moments as well. So pull them out. Should have done x cubed plus 2x squared plus x minus 4. You guys good with that? All right. So just know that if we're talking area, think length times width. You're multiplying the two polynomials. Okay. Now, one last thing I want to mention, and then we're done. Look at letter H. So two things going on here. First off, we have what we call a scalar in front, which is a monomial that we're going to be multiplying in. And we also got that squared. So first off, you would expand this to look like this. Then you would do either a box or a FOIL for the two binomials. Now, to save time, I'm just going to go ahead and put the answer, but I'm just kind of telling you the process that you want to do first. So you would do the multiplication first. So that would give you x squared minus 20x plus 100. And then you'll bring down the negative 2. And then you would distribute last. All right, so this would be negative 2x squared plus 40x minus 200. All right. Now, you could go ahead and distribute to one of the binomials, but what I see happen a lot is that, and again, you're honor students, and I've been doing standard for a while, so, this may not happen to y'all, but what I see happen a lot is that they distribute first. What happens is they distribute to both sets of parentheses, not just one of them. Okay, so you could have distributed to one of the parentheses and got the same answer. But just to kind of alleviate that, just do the box method first. Okay, any questions on any of this? So I know we did like a whole lot today with the operations, but that's just because we had to get through them so we can go ahead and get into quadratics tomorrow. Okay, so your homework for tonight, you guys have like a solid 25 minutes to work on it, is pages 6 and 7. Yep. I love how I had to look at the page just to know it was. So 6 and 7 is y'all's homework for tonight. You can probably knock it out before class ends, honestly. Clark, I'm going to throw my pen at you. 6 and 7. So guys, use your time wisely, please.